Alright, so we are going to continue with question 9. So letters and packages can take up to 2 days to be delivered by Bhutan Post couriers. So we have a table, and basically, if you're sending a letter, right, the probability that it arrives on the same day is 40%, the probability that it arrives after 1 day is 50%, and the probability that it arrives after 2 days is 10%. So if you mail a letter, say on Monday, then the probability that it arrives on Monday itself is 40%. The probability that it arrives on Tuesday, which is after 1 day, is 50%. And the probability that it arrives on Wednesday, which is after 2 days, is 10%. All right. Is there any truth in the statement? If you post 10 letters on Monday, then only 9 of them will be delivered before Wednesday. So this statement is untrue. Any number of letters, can be delivered. For instance, the probability, so what they did was they added these two numbers up, right? So it says before Wednesday. So the before Wednesday just means Monday and Tuesday. So there is a 90% chance that it arrives before Wednesday, right? But this 90% applies to every single letter, right? So for every letter, there is a 10% chance that it gets delivered on Wednesday. So basically, you could receive all 10 letters on Wednesday, or all 10 letters on Tuesday, or all 10 letters on Monday itself, right? So it's not necessary that exactly 9 of them will be delivered before Wednesday. This is what we call the average value. So it's just the average value. In reality, the 10% chance for every letter could win, and you could receive all 10 letters on Wednesday. So that is, receiving 9 letters before Wednesday is just the average. So because you have a non-zero chance of receiving every letter on Wednesday, what could happen is that this non-zero chance, this 10% could win every time, and at the end, you could receive all your letters on Wednesday, right? So it's not necessary that you receive 9 letters before Wednesday and the last letter on Wednesday. It's possible that you receive, 0 letters on Monday, 0 letters on Tuesday, and all 10 letters on Wednesday. So that could work. So this value given is only the average value. All right, find the probability that when 3 letters are posted on Monday, none of them are delivered on Tuesday. All right, so the probability that a letter is delivered on Tuesday is 50%. So if I do 1 minus 0.5, which is 50%, I get 0.5. So this is the probability of not being delivered, right? On Tuesday. So basically, the probability of a letter being delivered on Tuesday is 0.5. So if you do 1 minus 0.5, you get the probability of not being delivered on Tuesday. And basically, this probability needs to win for every letter, right? So if you post 3 letters, we don't want any of them to be delivered on Tuesday. So we use the probability for the first letter, we don't want it to be delivered on Tuesday. So that is a 50% chance, right? Or think about it this way. The probability that a letter gets delivered on Monday is 40%. On Wednesday is 10%. These are the two situations that are favorable to us. We don't want a letter being delivered on Tuesday. So if you add them together, you get 50%, right? So basically, we want the first letter to be delivered on Monday or Wednesday, which has a 50% chance, the second letter and the third letter to be the same. So basically, if you put this in your calculator, you get 0.125. All right, so we are done with B. Find the probability that when a letter and a package are posted together, the letter arrives at least 1 day before the package. All right, so basically, we don't want the situation. So here's what we don't want. We don't want the probability of both of them arriving on the same day, right? We want the letter to arrive at least 1 day before. So here's what could happen. If I get the package on Monday, if I deliver on Monday, right, and I get the package on Monday itself, then it's not possible for me to get the letter before the package. So here's what could happen. I could get the package on day 2 and a letter on day 1, right? Or, so I can add, because these are going to be mutually exclusive, I can get a package on day 3 and a letter on day 1, or I can get a package on day 2, I can get a package on day 3 and a letter on day 2. So these are all the favorable outcomes that I have, right? So I need to add together probability. So what is the probability I get a package on? So this, let me call this day 1, which is the same day. Day 2 after 1 day, day 3 is this one, right? So what is the probability that I get a package on day 2? 55%. So that is 0.55, and a letter on day 1, which has a 0.40 chance of happening. A package on day 3, which has a 30% chance, and a letter on day 1, which has a 40% chance. Or I could get a package on day 3, so which has a 30% chance again, and a letter on day 2, which has a 50% chance. All right, so if I add all of these together, so this dot in the middle is multiplication, by the way. All right, so if I add these possibilities together, I get 0.49. And that is going to be your solution. All right, so 0.49 is your solution for C. So basically, you just want to list your favorable outcomes. So I need my letter to arrive a day before my package. So I can get my package on the second day and my letter on the same day. I can get my package on the third day and my letter on the same day, or I can get my package on the third day and my letter on the second day. So these are all the situations where it's favorable for me to receive the letter a day, at least a day, right? At least a day. So it could be 2 days before the package or 1 day before the package. So basically, these are all the favorable outcomes, right? So this one, I received the letter 1 day before the package. I received the letter 2 days before the package. And I received the letter 1 day before the package. All right, at least 1 day. So you need to think about the situation here. All right, the following histogram, so basically, let's check the y-axis, and we have a frequency density. So this is very important. We have the percentage of buses per minute. All right, so here's what this means. You take the number here, right, 1, and basically this is the delay time, 1 minute, right? So 1 minute times 20. So if you multiply, because these are percentage of buses per minute, right? So if you multiply this, because 1 is in minutes, so you get the percentage of buses that are delayed by 1 minute. And that is going to be the area here. So the percentage of buses that are delayed by 1 minute is 20%. All right. So the percentage of buses that are delayed by between 1 and 3 minutes, right? So you find the area here, 15, and this is 2, so you'll get 30%. You find the area here, 3 to 6, that is 3 times 10. This is 30%. And this is 4 times 5, so you get 20%. And if you add everything together, 20, 30, 30, 20, you get 100%, right? That represents all the buses. Now here's how to interpret this. This represents the percentage of buses that are late by 1 minute. This half, so if you sort of take these together, right? This is going to be the percent of buses that are delayed by 2 minutes. These are going to be the percentage of buses delayed by 3 minutes. These are going to be the percentage of buses delayed by 4 minutes. These are going to be the percentage of buses delayed by 5 minutes, right? And so on. All right, so we are selecting 2 buses at random, and basically one bus being late is not going to affect another bus, right? So we're going to assume that the buses being late are independent, right, of each other. So both departures were delayed by less than 4 minutes. So let's look at here. We have 20% of buses that are delayed by 1 minute. We have, if you add 20 plus 30, at least 50% of buses are delayed by less than 3 minutes. And we want to know less than 4 minutes. So we want to know how much this is, right? So if this whole thing is 30%, then these are 3 equal parts, right? I can divide it into 3 equal parts. 1 part, 2 part, 3 part. And each part is going to be 10%, right? So that it adds to 30. So I just need to find 10%, 30%, 20%. So that's In total, 60%. So the probability of one bus being delayed by, so the probability that a bus is delayed by less than 4 minutes is 60% or 0.6. And I need this to happen for both buses. So I just multiplied them together. First bus is delayed less than 4 minutes. There's a 60% chance. The second bus is delayed less than 4 minutes. There's also a 60% chance. If you multiply them together, you get 0.36. All right. And part B says, at least one of the buses departed more than 7 minutes late. All right. At least one of the buses. So what we could do is that we could say, hey, the probability that at least one bus, so I'm going to say at least one bus that is 7 minutes late, this probability is going to be equal to 1 minus the probability that both buses, right? Because both buses being 7 minutes late is going to be the complement of this event. So 1 minus the probability that both buses are delayed by more than 7 minutes. Sorry, this is not the complement. Okay. So the probability that at least one bus is 7 minutes late is going to be 1 minus the probability. So what is the complement? What is the opposite of this happening? Well, the opposite is that both buses are delayed less than 7 minutes, right? That is going to be the complement. So the probability that at least one bus is delayed by 7 minutes, the complement is that both buses are delayed by less than 7 minutes, right? So if you do 1 minus, what is the probability that both buses are delayed by less than 7 minutes? Well, let's find out. This was, if you remember, 20%, 30%, 30%, right? So we have delayed up until 6 minutes. So we're going to consider everything here, right? So that is already 80% of the buses up until this point. 30 plus 30 plus 20 gives me 80%. And now let's see. This, if you remember, the whole thing was 20%. Now let me divide it into 4 equal parts. If I do so, each part becomes 5%, right? So this part is going to be 5% up until the 7-minute mark. So the probability that a bus is delayed by less than 7 minutes is 80 plus 5% is 85%, right? If you add all the numbers here. All right, so the probability that a bus is delayed by less than 7 minutes is 0.85, and I need this to happen for both buses. So if you solve this, you're going to get the answer, which is 0.2775. All right, and we are done. Arun wants to speak on the phone with his friend. When his friend's phone rings, he answers it with a constant probability of 0.6. If Arun's friend does not answer his phone, Arun will call later, but he will only try 4 times altogether. Find the probability that Arun speaks with his friend after making less than 3 calls, right? After making fewer than 3 calls. So basically, what are the favorable outcomes? Well, the call goes through on the first call, right? Or it goes through on the second call. So these are the 2 favorable outcomes, right? So because we want to make fewer than 3 calls. So we either get through on the first call or we get through on the second call. All right. So basically, when his friend's phone rings, he means his friend, right? Answers it with a constant probability of 0.6. So basically, if Arun wants to get through the first time, well, there is a 60% chance, right? If he wants to get through on the second call, well, his friend should not pick up when he calls for the first time, right? And he should pick up when he calls for the second time. So this is going to be your solution. So here, getting through on the first call, there is a 60% chance that his friend picks up. But if I want to know the probability that his friend picks up on the second call, well, he should not be picking up on the first call. So what is the probability that he does not pick up a call is 40%. So 40% on the first call, and then he picks up on the second call, which has a 60% chance of happening. So if I add this together, then the probability is 0.84. That is the solution. All right. Let's go here. Okay, so we need to find the probability that Arun speaks with his friend on the telephone so he can pick up on any one of the 4 calls. So this is going to be equal to the 1 minus the probability that his friend does not pick up at all. Right? So if I do 1 minus the probability of not speaking altogether, then I get at least 1 pickup, right? It doesn't matter on which one. Does not pick up at all. So 1 minus, well, what is the probability that his friend does not pick up on the first call? 0.4. On the second call, 0.4 as well. Third call, 0.4 as well. Fourth call, 0.4 as well. So I get 1 minus 0.4 to the power 4. And if I solve this, I get 0.9744. All right. And we are done. Each day, Selden randomly selects and buys one of the 4 fruit juices available at a local shop. Find the probability that she buys the same fruit juice on 2 consecutive days. All right. So let's think about this. All right, so the wording is a bit vague here. All right, so I'm going to show you 2 ways how to approach this, right? All right, so we are going to continue. So each day, Selden randomly selects and buys one of the 4 fruit juices available at a local shop. Find the probability that she buys the same fruit juice on 2 consecutive days. All right, so let's first of all think about the total outcomes. Well, on the first day, she can buy any one of the 4 juices. On the second day, she can also buy any one of the 4 juices. So you have 16 possible outcomes. Let's look at the favorable outcomes. Well, on the first day, you can buy any one, right? Any one of the 4 juices. On the second day, you have to buy the same one because we are looking for when we buy the same fruit juice on 2 consecutive days, right? So that is just 4. So therefore, the probability of buying the same fruit juice on 2 consecutive days, I'm not going to write everything there, is going to be the favorable outcomes, which is 4 over 16, which is just 1 over 4. All right. So 3 different fruit juices on 3 consecutive days. All right. So let's look at the total outcomes again. We can buy 4 juices on the first, 4 juices on the second, and 4 juices on the third day. So we have 64 outcomes, right? So my denominator is going to be 64. Now let's think about the favorable outcomes. Well, on the first day, I can buy 4 different types of juices, right? On the second day, I need to buy something different. So I have 3 choices. On the third day, I have 2 choices, right? So basically, I have 2 times 2 times 3 times 2. I wrote 4 as 2 times 2. Divided by 64 is 2 times 2 times 2 times 2 times 2 times 2. So it's 2 raised to the power 6, right? And if I cancel 3 of them, I get 3 over 8. So that is going to be your solution. So I hope that was clear, right? 3 over 8 is going to be your solution. So total outcomes, you can buy 4 juice on the first, 4 choices on the first day, 4 choices on the second day, 4 choices on the third day. So total outcome is 64. but you need the juices to be different, right? So on the first day, you can choose 4. On the second day, because you've already chosen 1, you need to choose something else. You can choose 3. And on the third day, you need to choose 2. All right, so that's 3 over 8. And we are done. A coin is biased. So I'm going to erase this, if that is okay. All right. A coin is biased such that the probability that 3 tosses all result in heads is that thing. Find the probability of obtaining no heads with 3 tosses of the coin. All right. So a coin is biased such that the probability that the 3 tosses all result in heads. So let's see that the probability that the first toss, so the probability of head, right? So we are tossing a coin 3 times. Let's say these are our 3 tosses, right? First toss, second toss, and third toss. And basically, whatever the probability of heads is, so we want a heads on the first, we want a heads on the second, and we want a heads on the third, right? And because these are independent, because one toss does not affect the another, and because it's like first head and second head and third head, we need to multiply these 3. And basically, when we multiply these 3 values, all 3 tosses all result in heads is this number. So it's 125 divided by 512. So basically, probability of getting a heads on one toss cubed is 125 512. So if you solve this, you get 125 is just 5 cubed, 512. So if you take the cube root of 512, that is 8. All right, so 5 over 8. Find the probability of getting no heads with 3 tosses of the coin. So basically, you don't want a head on the first. So basically, you want tails on the first toss, tails on the second toss, and tails on the third toss, right? So if probability of getting a heads is 5 over 8, the probability of getting tails is 1 minus 5 over 8, right? So basically, this is going to be 3 over 8. So here, you're just going to get 3 over 8 cubed, right? 3 over 8 times 3 over 8 times 3 over 8. So that is going to be 27 over 512. All right, so that is your answer. 3 cubed is 27, 8 cubed is 512, and we are done. In a group of 5 men and 4 women, there are 3 pairs of male and female business partners and 3 teachers. All right, so let's move on. In a group of 5 men and 4 women, there are 3 pairs of male and female business partners and 3 teachers where no teacher is in a business partnership. So 5 men, 3 of these, because we have men and women pair in business, right? A man and a woman. So basically, if we have 3 pairs, then 3 men. So we have 2 male teachers who are not involved in business, and we have 1 female teacher, right? We have 2 male teachers and 1 female teacher. And basically, where no teacher is in, okay. One man and one woman are selected at random. Find the probability that they are both teachers, right? So 2 out of 5 men are teachers, right? So out of 5 men, 2, we have a 2 over 5 probability that he is a teacher, right? And then from the women, we have 1 over 4 probability that one of them is a teacher, right? So basically, it's 2 over 20, which is 1 over 10, is equal to 0.1 is your answer. The probability that they are both teachers. So from the men, we have a 2 over 5 chance, and from the women, we have a 1 over 4 chance. So if you multiply them together, you get a 0.1 chance that they are both teachers. All right, so in a business partnership with each other, all right, so we selected 1 man and 1 woman, and we want to find the probability that they are in a business partnership with each other. All right, so how many possible outcomes, total outcomes there are? There are 20 outcomes. Why? Because we can select 5 men and 4 women, right? The denominators will always multiply to 20, right? That is, so we are assuming that we are selecting one man first and one woman first. But you can always switch the order, right? You can select a woman first and a man later. That is also okay, right? So you can switch the order. Whichever you select first does not matter. So 5 times 4 is going to be equal to 4 times 5, right? So you have 20 different possibilities. All right. So now let's think about this. We have 5 men, M1, M2, M3, M4, M5. 2 of them are teachers, right? And we have 4 women, W1, W2, W3, and W4. One of them is a teacher. So let's say these are the teachers, right? M4, M5, and W4 are the teachers. So now, we have 3 choices, right? We have 3 choices of practically choosing a man, right? We can choose M1, M2, and M3. So we choose a man in a business partnership. And then we have, now we are not going to choose all 3 women, right? We just need to choose the partner. And whoever we choose, they are only going to have one partner. So that's going to be 3 over 20. And that is 0.15. All right. Each is in a business partnership but not with each other. All right. So now, again, we have 20 possibilities, right? So we have 3 choices for the man, right? And then we need to choose a woman. Basically, if we choose M1 and let's say W1 is his business partner, then we can't choose W1 because we don't want them to be business partners. So we either choose W2 or W3. So 3 choices, and then after that we have 2 choices. So that's 6 over 20. So that's 0.3. All right. So I hope you understood the gist of it. Yeah, it's 0.15 and 0.3. I know it's a bit confusing, but this is how you go on about it. Alright, so we are done with question 14. A biased die in the shape of a pyramid has 5 faces marked 1, 2, 3, 4, 5. The possible scores are this, and basically the probability of getting any value is okay. Find in terms of k the probability of scoring a 5. Alright, so probability of scoring a 5 is just p5, which is k minus 5 over 25. So that is what they want. Alright, less than 3. So less than 3 means probability of scoring 1 plus probability of scoring 2. Right, 1 and 2, these are the favorable outcomes. So basically you want to add k minus 1 over 25 plus k minus 2 over 25. And that gives you k plus k is 2k minus 3 in the numerator divided by 25. Alright, that is it. The dice is rolled 3 times and the scores are added together. Evaluate k and find the probability that the sum of the 3 scores is less than 5. Alright. Let's think about it. When we roll this die, right? When we roll this die, we either get 1, 2, 3, 4, or 5, right? We have to get one value. So I hope A was clear and easy. So if it was, I'm going to erase the solution here. All right. So when we roll a die, I need to get one of the values, right? I need to get either a 1 or a 2 or a 3 or a 4 or 5. And these events are mutually exclusive. I can't get 1 and 5 at the same time. So I can do P1 plus P2 plus P3 plus P4 plus P5 should be equal to 1, right? I should get at least one of them. So the probability that I get a 1 or a 2 or a 3 or a 4 or a 5 is 100% because I will get one of them, right? So P1 is k minus 1 over 25 plus k minus 2 over 25 plus k minus 3 over 25 plus k minus 4 over 25 plus k minus 5 over 25 is equal to 1. right? And now, if you simplify the numerator, you have 1, 2, 3, 4, 5. So if you add them together, you get 5k. Minus 1 minus 2 is minus 3. Minus 3 minus 3 is minus 6. Minus 6 minus 4 is minus 10. And minus 10 minus 5 is minus 15. And then if you multiply 25 on the other side, you are going to get this expression. So 5k is 40. K is equal to 8. All right. So the probability that evaluate k. So k is equal to 8. Find the probability that the sum of the three scores is less than 5. All right. So if you think about this, right? What are the favorable outcomes? Well, if I need a score of less than 5, then does 1, 1, 1, right? That works because the sum is just 3. 1, 1, 2. That works because the sum is 2. So let's just find the possible dice rolls. So I can get 1, 1, and 1. That works, right? Because the sum is 3. I can get 1, 2, and 1. Sum is 4. I can get 3, 1. So I need the sum to be less than 5, right? So 3, 1, 1 does not work. So I can't have 3. I can get a... So these are the only two possibilities, actually. I get all ones, or I get 2 ones and 1 2. Any other combination of dice roll does not work. So what is the probability that I get all ones? Well, the probability of all ones is, well, I now know that probability of 1 is going to be k is 8 minus 1 over 25. So that's just 7 over 25, right? So probability of getting 1 is 7 over 25 cubed, right? Because I need a 1 on all three rolls. So that is going to be 7 over 25 cubed in fraction terms. 7 cubed is 343 divided by 25 cubed is 15,625. All right. Probability of 2 ones and 1 2, right? Now, how are we going to find this? Well, let's think about this, right? This 2 can appear anywhere. I can get 2 on my first roll, I can get 2 on my second roll, or I can get 2 on my third roll, right? So I have 3 different positions where I can get a 2. And what is the probability of getting a 2? Well, the probability of getting a 2 is 8 minus 2, which is 6 over 25, right? And then, once I get a 2, in the other 2 remaining places, I need a 1. And what is the probability of getting a 1? Well, it's 7 over 25. And because I need to get 2 ones, right? Or I need to get 1 twice, I need to square it. All right. So 7 squared is 49 times 6 times 3 is 882 on my numerator, and my denominator is 15,625. So now I can add these probabilities together. So 882 plus 343. So if you add this and this together, you get 1225 divided by 15,625. And that is 0.0784. That is your solution. And I think if you write it as a fraction, if you write it, so k is 8, right? And this solution, if you write it as a fraction, is 49 over 625. All right. So 0.0784 is 49 over 625. Yeah, if you put it in your calculator. All right. So that is how you do 15. So I hope it was clear and I can erase it. All right. So a board game is shown on the diagram. It's just like a snake and ladders. They roll a fair die and then move their counters forward from the start. Okay, so if you somehow land on the colored square, then you go back. All right. find the probability that the player's counter is on the start after rolling the die once, right? So basically, you look at the diagram. You roll the die once. The maximum ordinary fear die only has 6 sides. So the maximum you can get is 6, right? So the furthest you can end up is here. All right, so if you end up here, so the only risk of going to the start is this square. And how much do you need? If you roll once, how much do you need? You need a 2. So you have a 1 in 6 chance. So if you roll a 2, now let us calculate that you roll the dice 2 times and then you end up on the start. So what's one possibility of that happening? Well, one possibility is that you get to 2, you go back, and then you get to 2 and you go back again, right? So you have to roll 2 times, 2 twice for that to happen. So that is just going to be 1 over 6 squared, right? So the probability of rolling a 2 is 1 over 6 on the first time, and then you roll a 2 again, and that happens, right? You get back to the start. So that is one option. Another option is that you roll a 1, and then you roll a 1 again, right? And then you end up back at the start. All right, so that's another option. The third option is that you skip these 2 possibilities, right? You get to somewhere, say, these 4 numbers. All right, you get to these 4 numbers. So what is the probability that you get to these 4 numbers in the first place? Well, 4 over 6, right? And then for each of these numbers, you can end up in the square, right? And the probability of ending up in that square after you get any of these 4 places is 1 over 6. If you get to 3, there is one number that will take you here. If you get to 4, there's one number. If you get to 5. So basically, for each of these, there is 1 out of 6 numbers that is going to take you there. Everything else is going to be safe. All right? Another possibility is that you somehow end up on this square. And that will only happen if you roll 6 2 times, right? And I believe every other option should be safe. So you could end up into this box, and you have 2 ways. You either roll 2 twice, or you roll 1 and then a 1. And then you could end up on this box. So on the first time, sorry, you have 5 choices, right? Because you could end up rolling a 1, and then you could end up rolling a 6 that takes you to the 7th box. All right, so you have 5 choices, and then 1 choice after that takes you to this red box. All right, and then the other option is that you roll a 6 and then you roll a 6 again. I think that is the only way to get to this final box. All right, so I believe we have covered all the cases. So if you add the cases together, you get 8 over 36, I believe. So if you add everything together, you get 8 over 36. And that is just 4 over 18. 2 over 9, I think. I believe. Yeah, 2 over 9. Yeah. So that is how you solve A part 2. So find the probability that after rolling the die 3 times, a player's counter is on 18. All right. So to get to 18, here is what has to happen. The maximum you can roll on the first roll is 6, and then another on the second roll is also a 6, and on the third roll is also a 6, right? That is all the maximum, and that will add up to 18. So to get to 18, you need to go from 1 to 6, 6 to 12. But remember, if you get to 12, you're going to go back to the start. So actually, there is no way of landing on 18. So the probability is 0. All right. Now we need to guess the probability that it's on 17. All right. And 17 is only 665, right? 17 is 6 plus 6 plus 5. It's only 1 less than 18. So we need very high numbers to get to 17. We need a 6 and a 6 and a 5, but we just need to figure out the correct order of this. So let's see. I get a 6 on my first roll. That is okay. Can I get a 6 on my second roll? That is not okay, right? So maybe 6, 5, 6. Does that work? So I can get a 6 on my first roll. 1, 2, 3, 4, 5. on my second roll, and 1, 2, 3, 4, 5, 6. This works, right? Can I get a 5, 6, 6? I can go to 5. 5 plus 6 will take me to 11, right? 1, 2, 3, 4, 5, 6. And then 6 again will take me to 17. So these are two possible arrangements, right? So we have two arrangements. And then rolling each number, I have a 1 in 6 chance, right? So 1 over 6 cubed. Or you can do, what is the probability? I roll a 6, 1 over 6. I roll a 5, 1 over 5. I roll a 5 and then a 6. So I have 1 over 6 cubed here. Plus the other possibility is the same thing. So it's just going to be 2 times 1 over 6 cubed. So it's going to be 2 over 6 cubed is 216, I believe. And that is 1 over 108. And that is your solution. And yeah, we are done with this topic. We have one more small topic and then we'll be done.